right, so I'm just going to walk you through a few basics of using past. So I have past here, and I have copied the data, both the environment, or I'm starting with the community data. So I've copied the community data from Excel, and I'm going to come over to past and hit paste. And what you can see first is that it pastes all of my headers here in row 1, and I don't really want that. I want them to be kind of up here where the A's and the B's are. And so the first thing I'm going to do is go up to column attributes, and I'm going to select this whole row, number 1, and I'm going to hit edit, copy, and then I'm going to select name, and I'm going to say edit, paste. And so now I've got the names in the right place, and then I can go here and I can say edit, remove. So I can remove that first line of code or of data. Okay, so that's the first thing I want to do. Now you can see that plot is the first variable here, and that's actually, it's important to keep track of the plot because you want to make sure that the community data matches up with the environmental data, but we're not really interested in plot. We are interested in stand type. Under type, I'm going to select group. This is my grouping variable. I want to see if there's a difference in the plant community, that's all of these species over here, by their stand type. Are they in a mixed forest stand or a conifer dominated stand? So this group is really important for me. So that's kind of how I get the data in. And then I'm just going to go through a little bit of the lab to help you out here. The first thing I want to do is to kind of take a look at some species diversity. I would love to do a species accumulation curve. I couldn't figure out how to do that in past. So I'm going to do what's called a rarefaction curve. I'm going to select just the community data. So from this 10 here, and then I'm going to go, oops, I got to get down to the bottom of my screen. Go all the way to the other side. I'm going to hold down the shift key and select just the community data. And so that, then I'm going to go up to, nope, I got to see the top. I'm going to go up here and click on diversity. And I'm going to select sample rarefaction. And then I get this nice curve. I hope you can see it. Let me just, I can't really tell if you can see it or not. Let's just hope you can. I'll talk about it for a minute and then I'll click out and do another short video on ordination. This shows you as the number of samples in your data set, the number of taxa with a confidence interval. So this is actually predicting the number of taxa in your in this study would be around 35. And yeah, so that's this first bit. And you can copy the graph and paste it into your lab. All right, then the next thing that we're going to do is an ordination. To run an ordination, we actually need to make sure that we select the group variable first too. So to do that, I'm going to again select from this cell. I'm going to go all the way over here, and then I'm going to go up to stand type. And so I'm going to hold down shift and hit the first stand type. So now I have stand type and all of my data selected. And now I'm going to go up to multivariate ordination and hit non-metric multidimensional scaling ordination. All right, so hopefully you can see this box, and you're going to click on whatever similarity index you want. Look at all these different, oh my goodness. We're going to go with Bray Curtis. And then we're going to pick a two-dimensional solution to start with. We're going to, we don't have any environmental variables at this point, so we're going to keep that 0. We're going to add convex hulls and group labels, and we're going to hit compute. So see how it took a little while. I was doing those different permutations, and so it shows our conifer plots here and our mixed hardwood plots down here. And so this is our axis 1, axis 2. Under graph settings, you can mess with some things. You can change the label. So instead of coordinate 1, most of the time it says axis 1, axis 2. I'm still, I don't use past myself. I thought it would be a good kind of easy way to introduce you. So one thing I would love to be able to do would be to color the different symbols, 2 different colors. I haven't figured that out yet. So if anybody figures it out, let us know. A few more things that are nice is it shows the actual values for axis 1, axis 2, the X and Y scores. If you wanted to make this graph in your own, like I could make it in Excel, and then I could give my different groups different colors of plots. It also prints out what's called a shepherd plot, which is basically kind of a correlation between ordinated, the rank that you got from the ordination versus the rank that should have come out of the data. And it gives you a stress value. Our stress value is 0.15, and it asks you to talk about stress in the lab. All right, so we can close that. And then you would go through those same steps to do a more complicated ordination that includes the environmental variables. Oh, and then of course, well, let's show you one more thing here. Let's go to multivariate and we go to tests. And now when we go to tests, we can choose a bunch of different things, a one-way anisim, a one-way permanova. Now we can't do an MRPP in past, but that's okay because we can try an anisim. I'll just go through an anisim real briefly with you. You can see here that it gives us the R value, 0.06, which is pretty low. But it is a significant p-value, so there is a significant difference. Now, it ran this on a Euclidean distance. I think Bray-Curtis is better, so I'm going to change that to Bray-Curtis and hit recompute. So it's changed the R slightly, and the p-value, it's still a significant p-value, less than 0.05, so I would say these communities are not the same. I reject the null hypothesis. And I don't really know what these are. These aren't really very helpful, but there's your anisim results. And you would do the same thing, multivariate test, and let's look at a permanova. So here we have a permanova. We're going to change our similarity index again and hit recompute. Now it gives me the total sum of squares, the within sum of squares. So with those, I could calculate the among sums of squares, right? It gives me an F value and a P value. It doesn't give me my degrees of freedom, but I should be able to figure that out based on the number of groups that I have in my categorical variable and the number of samples that I have in my study. So that'll be a fun thing to see if you can figure out your degrees of freedom. And again, I don't think this wouldn't help now because there's only 2 groups, but if you had 3 or 4 groups, you could do pairwise tests. And this would be like your Tukey's on a significant difference test. In this case, we don't have that option, but you could use Bonferroni corrected p-values would be a really good option there. All right, so there's your permanova, goes with your ordination in PATH.